Okay, so today we're looking at area of circles and sectors. It's actually very, very, very similar to what we just did in the last section. You're still going to write two fractions talking about a portion to a whole and solve by cross multiplying. Okay, the only thing that changes is that instead of talking about arc length, so like picture a pizza, right? Instead of talking about the crust of the pizza, what are we talking about? The cheese and the pepperoni in between, right? So we're talking about the area of the pizza now, right? So rather than using a circumference formula, what formula are we going to have to work with today? Does anyone happen to already know what the area of a circle is? Pi r squared. Very good. Right, so the only thing really that's changing is the formula that we're using for the whole part of one of our fractions. So the area of a circle is pi r squared. Notice that that is really similar to a circumference. What is the circumference formula? 2 pi r. So in the circumference formula, we multiply by 2. Uh-oh, hold on, sorry. I didn't mean to do that. In the circumference, we multiply by 2. In the area, we square the radius instead. So it looks similar. Make sure you do not mix those two different formulas up and use them incorrectly. When we're talking about the sector, notice that our setup looks really similar to what we did in the last section. We're still comparing angles, right? So we're still doing the portion of an angle to the whole 360. The difference is that if I want to find the area of a sector, then when I'm looking at the sector area, I need to compare it to the total area rather than the total circumference. They need to be like things, right? If I was trying to find the arc length of that sector, then I would use circumference because distance and distance are similar. Distance and area are not similar. So if I'm going to find an area of one thing, then I need to find the area of the whole thing. But you can see it's really similar setups, right? So let's take a look. And actually, there's a part A and B. Give you guys a second to copy this down. All right, so for the first one, we're using the area formula. What is the area formula of a circle? Yeah, so we should be looking at the area equals pi r squared, and then plug in what we know. So first of all, for that pi, am I supposed to be using pi or am I supposed to be using something else? 3.14, that's what the directions said, right? So I'm going to replace the pi with 3.14, and then I'm going to take the radius, which is 8, and square it. Can anyone tell me what I should have gotten from this? 200.96. Very good. Okay, are there any questions on that? You got it? Okay. Part B, am I still talking about the area of a circle? Yes, I am. So am I changing the formula that I'm dealing with? No, I am still talking about the area of a circle equals pi r squared. What's the thing that changes in this problem compared to the first part? Right, so this time I don't know the radius, right? If I know the radius, then I'll be able to find the diameter. But what variable do I know in that equation? Area. So I plug in 96 pi equals pi r squared. How do I go about solving this? What do you notice? If I divide by pi, what happens? Cancel and cancel, right? So I lose my pi's and I'm left with just that r squared is equal to 96. Okay, now I was told to give my answer as a simplified square root, right? So when I'm doing this, I have to think about the fact that I've got r is equal to the square root of 96 after I square root both sides. What divides 96 that's a perfect square?
16.
Right, so I know that this is equal to 16 times 6. And which of these two numbers can pull out of a square root perfectly?
16.
And it pulls out as 4. So I just get that r is equal to 4 square root of 6. And I am done. Oh, I have to find the diameter. Thank you. Woo! Almost forgot. So all of this can give me the diameter very easily, right? What is the diameter going to be equal to? 2 of the radiuses, right? And one of my radiuses is 4 square root of 6. So what is this? 8 square root of 6. Yep. Just multiply the 4 and the 2 outside of the square roots.
It's a centimeter squared, so I assume the area was 96 pi squared.
Oh, no, so that anytime you see the units squared, that's area is always given in terms of units squared. So on the first one, I should have and could have written inches squared. Right? That's just the way we notate area. All right. Let's take a look at example 2. So for this example, I am now ready to find the area of sectors. Now notice that I asked for the area of sectors plural. So I'm going to have to give, in the end, both the area of this piece and then separately the area of this piece. Okay? And I'm rounding my answers to the nearest tenth. Does that mean I'm using 3.14 if I'm rounding answers to the nearest tenth? No. What am I using to round? The pi button on my calculator is what I'll use when I'm doing these computations, and then I'll round that to the nearest tenth. All right. So this is when I'm finding the area of a sector. Remember, you're setting up your 2 fractions that describe portions to wholes, right? So your easiest one that you can set up, what's the easiest fraction here that you can set up? 135 over 360. So you can compare the angles right away, right? Sorry, I'm not sure why the screen is freaking out right now, but we'll hope it hangs in there. So I can say that 135 is to 360, right? That talks about how much of the circle this little portion is making up. What's another way that I can talk about how much that portion of the circle makes up? I can say that the area of the sector over the area of the whole circle, right? Now, can I find the area of the whole circle? Okay. Whoa. How do I find the area of the whole circle? Oh, sorry. So pi times 11 squared. I'm going to leave this in terms of pi for right now. Guys, I need the side conversations to stop, please. It's getting very distracting. All right, so I'm going to leave my answer in terms of pi until the very, very end, right? Otherwise, I'm going to pick up a round-off error throughout my calculations. So if I just leave it as pi, it's exact for now, right? All right, come on over here. And now I can start plugging stuff in. So I'm going to replace this area of hole with the area of the hole, which was 121 pi. All right, so if I cross multiply, and you can do reducing first, so some of you guys will prefer to like simplify that fraction if you can first. You don't have to though, right? It'll still work out. Why don't we go ahead and simplify it just so that we can see what happens? What divides both 135 and 360? 5. Okay, so let's, and I actually see another bigger number that divides both of them. You might have to do a little bit of work together. So let's just do 5 for right now. What's 135 divided by 5? 27. What's 36 divided by 5? 72. And I'm just going to shorthand the area of the sector with A sub S for right now. Okay, do you see 2 more numbers that divide both 27 and 72? 9, right? So 27 divided by 9 is 72 divided by 9? All right. Okay, how am I going to solve this? I can either cross multiply, or is there an easier way just to get A sub S by itself? Multiply by? Right. So I can just multiply by 121 pi to cancel it off of this side onto this side, right? So what do we have left? What's 121 times 3? 363 times pi over 8. Am I now to the point where I can plug this in on my calculator? Yeah? Yeah, I can plug this in on my calculator. Can somebody type out for me 363 times pi over 8 and tell me what we get in terms of the nearest tenth? What? 142.5? Okay. Am I done answering this question? Huh? Right. So technically all I have found right now is the area of this sector right here, right? But if you read the directions, it says to find the area of the sectors plural. What's a very easy way for me to find the area of, let's call it A sub S2? What's an easy way for me to find the area of the second sector now that I know the area of the first sector? Right. So the area of the second sector is going to equal the whole entire circle, which is 121 pi. So taking the area of the whole thing and subtracting out that 142.5. Can somebody tell me what they get? So you're typing into your calculator literally 121 times pi minus 142.5. 237.6. All right. And then that is the area of the other sector that we were supposed to find. And we're done. Are there any questions on finding the areas of sectors? Again, really similar to the setup you were doing the other day. It's just that instead of having one of your fractions talking about arc length to circumference, now that fraction's talking about area of a sector to area of the whole, right? That's the only thing that's changed. Let's take a look at another one. Okay, so for example 3, we want to find the radius of a circle given that the sector formed by a 70-degree central angle has an area of 20. So let's draw a picture so that we can kind of see what's going on here. So I've got a circle. I am going to be looking for the radius, right? I don't know it quite yet. That's what I'm looking for. But I'm told that a sector with a central angle of 70 degrees, so something kind of like this, with 70 degrees in that central angle, I'm told that that has an area in here of what? So the area of this thing is 20 inside, right? All right, since I'm told the area of the sector, I know I'm going to be using that fraction in terms of area. So first of all, what's the first easy fraction that you can write?
70 over 360.
Right, that one's simple enough, right? So I would write 70 over 360 is equal to, and what would you set it equal to?
20 over R.
20 over, not R, it should be 20 over the whole area of a circle. What is the area of a circle, though? Pi r squared. Can you solve that for r? Yeah, we should be able to, right? Cross multiplying is going to be the easiest way to handle this one. You might simplify a couple things first, so you might knock off the zeros on this so that I don't have such big numbers. Now when I cross multiply, I get 70 times pi r squared equals, and then 36 times 20, which is 720, right? Oh, I knocked it out. That's right. Thank you. So 72. Thank you for catching that. Yeah, because I got rid of the 0. Oh, it is 700. What?
It's 700.
Oh, I see what you're talking about. I was right on that one, but I was wrong way back here. So that should be 7 pi r squared. Thank you for catching that. 7 pi r squared, and then that should be 720 because of the 0 on the 20, right? Okay?
No, just 75.
Nope, because of the 20. So I lost that 0 on the 36, but I'm multiplying it by 20. All right. So now what am I going to do to start getting r by itself? What do I want to divide by? Do I only divide by 7? I should probably divide by 7 pi, right? Because I want to get r by itself, so if I can cancel all of that stuff, then I'm left with r squared equals 720 divided by, and when you're typing in this into your calculator, you're going to be doing 7 pi in parentheses, right? To get r alone, you need to square root both sides. So you're literally going to type this whole thing into your calculator. You're going to open up the square root key, type in 720 divided by, then you're going to want to enter parentheses 7 pi parentheses. So on your calculator, this is going to look like r equals, you're going to open up a square root, it's going to look like that, right? It's going to open up a parenthesis for you. Okay? You are going to type 720 division key. I think it will show up as a slash though for you guys, won't it? Like that? Is that right? Okay? And then you need to open up a parenthesis and type out 7 pi, close your parenthesis, and then you also need to close the last parenthesis that was opened right there. Okay? What did you guys get? What was that? 5.7-ish? All right. So then you found your radius. Are there any questions on that? Again, it's all about getting this set up here. You're always using the angles, right? And then sometimes you'll be using area, or from the last section, you'll be using circumference and arc length. On the test, you're going to have to put 2 and 2 together. Okay, I think I just have one more example. Okay, find the area of the shaded region. And this is actually easier than the last 2 problems that we did. How are you going to find the area of the shaded region? What technique are you going to use here? Yep, so you're going to find the area of the rectangle, and then from it you're going to subtract 2 areas of the circles, right? All right, so now the only thing is, well, how do I find the area of the rectangle if I don't have any dimensions? What dimension did I give you? The radius. So if you look here, if I were to draw the line straight through the circles, you'll notice that what that does, give me 1 second so you can kind of see. If I were to put the center point on each of the circles, right, you can see that how many radiuses go all the way across this thing then? 4 across the whole thing, because you get a radius here, a radius here, a radius here, and a radius here. So total, how much is that? 16, right? Similar to that, you can find the height of the box by looking at the vertical radiuses, or radii, and you'll notice that you have just 2 4s going vertically, which make up 8. So when I am finding the area of the rectangle, what are my calculations? 8 times 16 minus 2 times, and then how do I find the area of one of the circles? Yep, it'll be pi times r squared, which will be 4 squared. And 2 of them because I have to subtract 2 circles total, right? Okay, what is 8 times 16? 128 minus 2 times, and then you'll notice that the area of one circle can be written as 16 pi after you square the 4. So that will be 128 minus 32 pi. Now if I ask you to leave it in terms of pi, this is as far as you can go because 128 and 32 are not like terms with the pi on one of them. They would both have to have a pi if I wanted to combine them. If I asked you to round, then you would just type that out on the calculator and round it. But we'll leave it here for this problem. Are there any questions on how to find that? No? All right. There is your homework. This will be due tomorrow. And you've got a little over 15 minutes, so you can probably get through half of this in class.